Hello, everyone. I am Drew Ackerman. This little presentation will be a lot of information that I gathered from the StarEast conference, which is this one specifically about QA, the QA industry, the sphere. The things we'll be going over today are quality engineering, agile processes, enterprise test data, performance testing, QA team setup, which will be kind of cool, and then a little bit about the AI and what that's going to be looking like for QA. One thing I want to keep in mind during this whole presentation is this idea of quality engineering and how that differs from quality assurance and the various qualities of quality engineering and how different things we're going to be talking about in each section relate back to trying to improve risk management or trying to improve processes or trying to make validation of the functionalities that we're constantly testing easier, and then also taking like a look at tools or methodology that can make quality management proactive instead of a last minute type of ideology when it comes to software development. And overall, the idea is to shift the QA process left in the design, or not in the design, but in the software creation process. This idea of not waiting until the end to do quality assurance, but trying to incorporate different processes throughout software development. When it comes to agile, there's this terminology called cargo cult agile. This idea that when teams first adopt agile, they usually adopt tools and metrics and ideas from a template without really understanding what those processes are and how to utilize them best in their organization and how to change processes when necessary to adapt to the organization's overall process. So some common things that occur with cargo cult agile is the idea that metrics become how we measure progress. A really big one would be velocity, and always looking at velocity and seeing that if velocity is increasing or the amount of story points that is increasing in a given sprint, that means that the team is being more successful in their development. And that's not necessarily the case. Another thing is an over-reliance on the tools that we use in Agile, and saying that as long as we adopt these tools and methodologies, we are doing Agile correctly, and there is no downsides to how we're going about it. And then again, another issue is resistance to change. So trying to not adopt experimentation and learning from the failures over time and saying, well, this is how we've always done it. This is how we're going to do it. If we change it, we're not going to gain anything from that. If anything, it's probably dangerous if we change, so let's not change. If you don't change, or you rely too much on tools, or you rely too much on metrics, that leads to stagnation and frustration, which over time leads to issues in quality. And you'll see it slowly progress. It doesn't seem so bad at first. It's just, oh, well, one thing over here, one thing over here. But over months and years of a product, it quickly becomes an issue. So when we're talking about agile metrics, there's two main things that really stood out. And one is Goodhart's law, which is when a measure becomes a target, it ceases to become a good measure. And that's this idea that sometimes you set out with these great measures. You say, you know, we're going to really look at something like, again, velocity, for example. And as long as velocity is increasing, we're doing really good. It's a good measure. But you'll notice over time, what happens is developers and management look at velocity as the goal and saying, what we're going to do is maybe we have to skip quality over here, or we're going to do poor implementation of a feature over here because that lets us get this ticket done, and then we can pull in another ticket and we can continue with this velocity. We can get faster and faster and faster. And you're not noticing the negative effects that occur because of, again, that survivorship bias, this idea that decisions are based on successful outcomes means that the process is successful, rather than looking and saying, well, yes, this was successful, but we also need to look at the failures of it. And you'll see that over time, you start to gamify these metrics. So like the developers try to increase their velocity, management tries to stuff more tickets in to make their velocity go on, but you're not seeing the downsides of that. We can shift agile metrics, and we can identify ones that really rely on that Goodhart's law, and try to shift it away from what is something that we can explicitly measure and try to gamify, and try to change it to definitely a more holistic, or something that it requires both a quantitative and a qualitative value to it. And it seems like that's a really poor thing to go from, because if everything's quantitative, then everything's numbers, and we can track those, and we can see how things are improving or how things are getting worse. But that's not what ultimately matters when we're developing software. There's a lot of small qualitative values to software development that matter, both on the development side and to the customer. So if we identify these poorer metrics, then maybe we can identify better ones. So if we look at velocity, for example, how could we change that? Well, we could change that to something called value delivered, where we're looking at how it does our work align with the overall strategic goal. How has our planning been? How has our accountability been? And how are we changing these processes to be better for us? And that's a very qualitative one. If we go to number of defects, just tracking how often an issue occurs, or how often issues in general occur, and we say, that's really a cool number if we could get that down, but then how do we get that down? Well, let's shift it to a different one. Let's shift it to mean time to recovery, and say, mean time to recovery is, if a defect occurs, how long does it take for us as a team to identify it, come up with a fix, and deploy that fix? What's that timeline look like? And the overall benefits of something like that is, if a customer notices an issue, then you're increasing their satisfaction, because you now know how long roughly it's going to take to address their issue. You can be proactive in problem solving, because now you've seen that how long it's taking you, and so now you can start identifying areas in that process to say, yeah, it takes us several days to figure out how we're going to address this issue. What are ways that we can figure out how to reduce that? Oh, it takes us too long because we have a bottleneck on a certain developer. What are ways that we can reduce how long that bottleneck takes, so that we can address this issue that's arisen? If we look at lines of code, that's usually a really poor metric, because just because you write more code doesn't mean you're actually writing either quality code, or you're writing code that you're not going to have to revisit down the line and spend more time doing. So if we change that to code quality, we've gotten away from a quantitative idea to a qualitative idea. And with code quality, now you're looking at how healthy is our code? How much tech debt does our code have? How much automation do we have in detecting these issues, and what can we do there? And with lines written, you don't have any way to address those issues. You just look at, oh, yep, he wrote 1,000 or he wrote 100. Well, if you start using tools and some analysis by just the developers when the code's changing, you can say, oh, wow, we have an issue here where we design this kind of component and it continues to bite us in the butt often. So let's try something different. So again, you're getting away from that quantitative, you're going to qualitative. If you look again at numbers of passing tests, that's really great. And it seems like it's really great until you realize that doesn't give you any kind of data off of it. You're looking at a percentage saying, yeah, 90% of tests pass, but that doesn't give you this idea of what okay, why are those 10 failing? Or sure, we have 300 tests, but what do those give us? And so you shift it to testing effectiveness and you start trying to measure, okay, well, we have tests in this one area, but for some reason, so many more bugs are coming out of this area. What do we do? What does that mean? So you start tracking defect escape. So you start saying, yep, every week we have about 5 defects that come out of this area. What's things that we can do to try to shore up? Do we need more tests? Do we need to redesign that area? And it allows you to start this idea of looking at where you also need to allocate resources rather than saying, yep, we just need more tests, to say, well, we do need more tests, but we also need to allocate resources to to 50% increase over at feature A, and we're going to actually cut back on feature B because we don't have as many defects coming out of feature B. So we're going to maybe do a little less testing over there as we're trying to roll out tests. So it's another shift. And we gotta, when we're trying to come up with these metrics for Agile, we got to continue to think about what helps the overall code instead of what just looks nice as a number, what looks nice on a report. Shifting away from quantitative and trying to introduce a little bit more qualitative, and also trying to figure out a way to measure that too. So we shift from Agile, and we're going to go into enterprise test data management and some of the things that were introduced at this conference there. Some of the issues with enterprise test data management. So some of it is when you're talking about the enterprise level, you're talking about many systems that are probably integrated and talking to each other. You're talking about systems that are built in different languages or different frameworks or different versions of those languages and frameworks, and they're all going to be different, and some can even be so old that they're deprecated and you're just trying to keep on life support. So what does testing like that look like? Sometimes you have really great documentation, in other areas you don't have great documentation. What are ways that you can try to address those issues? What's a good way of trying to bolster that area? And then the idea that you're trying to play catch up sometimes, and then as you just implement a new solution, someone comes in and says, oh no, we have another product coming in and that's going to change this one over here. What are ways that we can guard against that? What are ways that we can create robust test data around that? So some of the ways, it kind of seems counterproductive. Don't test everything. Try to focus a lot on the core features. There's going to be some areas that you can't automate. There's going to be some integrations between systems that it's going to be better to manually test those systems due to the complexity of the test, or maybe there's just so many side effects, or it's just a very difficult thing to make realistic automation for. You can try to establish clear interfaces. So that's, again, kind of making a wall of this application saying, like, this is how these two talk, and having tests around that and trying to carve up the areas that you know aren't going to change. Try to prefer granularity. So when you're looking at your overall test scape, you have usually unit level tests, and then functionality tests, integration tests, UI tests, and they're all different levels, and people have different definitions on like where those end and where they start again. Definitely prefer to try to keep things as much as you can in those areas. So trying to say, I have 3 systems, but I'm going to try to isolate the test for all of them rather than creating one test that goes through all 3 systems. It can be a lot more beneficial to create a test that is just addressing a single system, and trying to get as many of those as you can, and then start to do the tests that go through the whole system, but making those very general and not as specific. It seems like it's very convenient to test that way, because you say, well, if I test A, B, and C all in one, then I know like the system, when it's all integrated and it's working together, it will work. And that's true until you encounter an issue in B, not in A and C, and now you have no test cover. You have nothing to rely on. And so now you're trying to resolve this test issue, and maybe you have to fall back to a suite of manual tests when it would have been better to have at least some sort of backbone between the different products. And then test clarity is a big one that you'll see everywhere, and especially here, but definitely everywhere. Always prioritize test clarity over test cleverness. And that's because when a test breaks, we want to try to resolve those as quickly as possible. And the more time that developers or QA have to spend fixing those tests, it just takes longer and takes more time. One of the things to do for test clarity that's really helpful is this idea of Chekhov's shotgun, which is try to reduce the amount of code in a test and try to focus on what that test is doing. A big one is sometimes you'll make a test that is testing a specific area and you'll give it this huge like data object, this huge thing that has 100 fields, and all you really needed was like 5 of them. But the way that you've structured your test is you didn't really have a way to only give it the 5 it needs. And so now you need to give it this big object. So when something breaks, someone's scrolling through all these lines of code and it might not be very clear what properties are imperative to this test. And that's a thing that can go, this ideology of trying to just keep them pared down as much as possible and trying to make it easy to read is at every level. So you should apply that to the granular level tests and all the way up to even the integration tests where you're hiding away some of the implementation where it makes sense for maybe the arranging and the setup of your test, and trying to hide some of that low level setup code behind like a function or class that's easy to use. And someone can read that and say, oh, this function's like setup data function, and a better name than that, hopefully, but setting up X amount of data rather than saying the whole setting up the class yourself. Using some sort of like builder class or pattern can sometimes be really helpful when it comes to managing the test data for your tests. We're going to shift from enterprise test data management to performance testing, which is super crucial. And it's another idea where we want to also try to shift performance testing left again. And most of the time, when you're doing performance testing, it's kind of an afterthought. You build this huge system where you have all this functionality, and then someone at the very end says, hey, we have this requirement that this workflow needs to occur in 4 seconds. And then you're like, okay, cool, I'll make the stress test. You make the stress test and it comes out at 6 seconds, and you say, it's at 6 seconds. And everyone says, well, I don't know how we're going to fix this and make it 4 seconds when we deploy in 2 weeks. We don't even know exactly where this issue is coming from. But if you had set this up ahead of time and had some sort of stress testing before you're deploying all these features out, there might be there usually is an opportunity where you introduce new code and you've run a stress. You've created this baseline of 4 seconds. Everything's great. You make a new feature, everyone's testing it, stress tests go out, and it's at 6 seconds, and you know somewhere in this change something happened and we lost performance. And it's a lot easier to work with that and to plan around that and to address those issues at that spot rather than to retroactively try to figure out where in your code this issue is occurring. So when we're talking about performance testing, we need to make sure that we have this idea of a realistic environment. We have this idea of testing before deployment. And then we have this idea that when you are doing performance testing, it requires API knowledge almost always. And that's probably not just almost always, that's probably always. There's very little performance testing you can do where you're not going to have, where you don't need to know what that API looks like, because you're usually making direct calls to that API in a chain to simulate what the user is going to go through in a normal workflow. I want to just cover really quickly the types of performance testing, because sometimes people forget the differences between them. So we have a soak test, which is you set up the system and you just run a really long loop of a workflow. The main purpose of doing this is to see, is our system stable over time? Or does an issue arise? Do we not properly manage some sort of memory? Is our system going to crash after 10 hours and reboot because we've taken up too much memory and the server kills it? are we going to have an issue where, oh yeah, we're doing really great on our usual responses, but it turns out we've created a system where over time our queries just take longer and longer, and our system doesn't crash. It's just now things are taking 4 seconds, 6 seconds, 10 seconds. What do we need to do to address that issue? A stress test was when you would be loading past the maximum load to see at what point at what point of traffic does our system handle before it's not stable anymore, before it starts to see inconsistencies in its behavior. It doesn't mean it crashes, just means it's not doing what we would expect it to do. Peak would be higher than normal load, but lower than the max load that we defined usually in our stress tests for a certain amount of time. Something like you have an event system and every Sunday everyone uses this thing on Sundays. So you're just testing to say, on a normal Sunday load traffic, can we handle that? Does our system degrade to unacceptable levels, or can we still process those requests? A spike is taking that to a next level and saying, we're gonna have a huge, more than the max that we usually have, 2, 3, 4 times as much traffic. What happens during that time, and what can we do to address it? There's also a really important distinction between API testing and workflow testing, when you can isolate your stress testing to a specific set of APIs so that you are focusing and saying, we're gonna hammer this specific type of request and see how our service can handle it, versus a workflow will have usually multiple API calls in it and a mix, and you have some weights in there because the user's doing something, and then you expect after this amount of time something's going to happen. So you'll see a lot different responses between those two. So when we're designing performance testing, we need to keep both in mind and what's important to our system. There's a really cool idea at the conference by a presenter, this idea of, it's not often, but it happens, where someone has to create a QA team from scratch as their first time. So what are some helpful tips that they can step into it, and what is some of the things that could get you started from 0 to day 1 with something that you can hopefully present as a QA solution in their first couple of sprints? So one of the first things would be to have a quick start guide, which is really important. This idea that it contains everything that someone would need to be productive day 1. And this can be both for QA and for dev. And devs usually do have some sort of quick start guide. They say, you need to download this software, you need to get this access, you need to do this, this, and that. You're good to go. It's actually pretty rare that QA develop a system themselves that's not some tribal knowledge that you're just told because people know, because this is what they did and this is what they know you need to do, but rather having that guide as part of like a wiki documentation that you can direct someone to and say, look, you also need access to this, but you need access to this and this and that, and you need to talk to this person over here to get set up with this. And I think that's a really cool idea to take away from that. Another one is obviously keep this idea of test case software in mind. A lot of teams start with an Excel spreadsheet when they're really small, and that becomes really unwieldy. So skip that step. There's really good low-cost software out there that you can use that can help you manage your test cases. That's going to be worth the couple of dollars a month. This idea that the software can handle your requirements, your use cases, edge cases, maybe it has some documentation, but that is enough to get you started. And there's other systems you can use that can help you on, but this is what you need at minimum to get started. Another idea is your MVP's test set. What's the test set that you want to start with that's going to give you the most bang for your buck when you're trying to develop a QA team for a product? And it's this idea of starting shallow so that you have a lot of good coverage on all the different areas in your product, and then you can go deep, and you're trying to get those happy paths, so at least you have something that you're testing against. And then you can also focus on some smoke and regression tests there, depending on issues that you see in the first couple of weeks. Yep, this is really important. We need to have a test over here because this is pretty flaky, and we want to make sure that our users have the base set of functionalities at all time. A debugging wiki is really neat. That can look very different for each team. I know on our team, we use Confluence, and we really try to store a lot of information when it comes to particulars about that we can reference in our test cases. So our test cases are set up that they can point to these Confluence documents. So if someone comes across and says, the test case will really say, test all translations. And then it has a link to this wiki. And the wiki's like, this is what we mean by translations. What we mean by translations is it has to follow these certain languages, and it looks like this on the page. And what's really great about that is because you put it in one area, when people reference it and you update that area, all those references are essentially fresh. So this was a really cool thing that we did on our team. Rather than storing those details in the test cases, one, now product owners know about it. Now devs know about it. They know what translation really means, what that requirement is. And then QA can reference that too, without having to dig into some weird test case that's probably not named correctly, super archaic, isn't really referenced as well. And then the two other things to keep track of when you're setting up a team is how you're gonna identify risk, what that means for you and your team, what areas are more risky than others, and then time management. Trying to come up with this idea of this area is really gonna be really important for us, and this area is less important for us, and how is that gonna shape the rest of our team? How is that gonna shape the test cases we make and the documentation that we create? A really neat thing, and it's kind of a double-edged sword at this conference, was the amount of AI and AI talks, and just the general excitement for AI was very, very high. And I can see why. There's a lot of interesting tools, and there's some less interesting tools that we'll go over in a little bit at a high level. It can kind of be frustrating when we're talking about AI because a lot of it's like, prepare for it. And then they just say, prepare for it. And we're like, prepare for what? What does that look like? How does QA adjust to AI software? When someone makes code, the usual thing is the developer has what that code is and what that looks like. And we can draw that from requirements or whatever. And then QA can look at the test cases and do that. But what happens if something's developed at such a large, it's just auto-generated in a way. Like we've had some developers try to do auto-generated test cases. What does that mean? How does that change our trust and our dynamic between dev? What happens if we do find issues? What happens if some bug is introduced due to that auto-generation? Who owns that? Who changes that? Who tries to catch that? What does that look like? And some of that stuff definitely seems like people have an idea of how QA can manage that, and sometimes it's just like we don't know yet. We gotta wait. We know it's coming. We're gonna see how this works, and we'll take a cautionary approach to it. Maybe we'll try to integrate with some of these new ideas, and we'll go from there. There's a lot of companies at this conference. I've listed all of them on the right, and they have usually some sort of system or set of systems that are doing something like on the left side. So for instance, I saw a lot of companies talking about automated test creators. So they'll look at your code, they'll create the test based off of that. There's companies that are looking at vision AI. So instead of doing test and defining tests in code, especially from like a front end or a mobile ideology, usually when I'm developing tests for that, I'm using a framework like Selenium or Cypress or Playwright to hook into that, and I'm physically writing code. And Vision AI, what they want to do with that is they want to say, I'll take a screenshot, maybe I'll scrape all that code off, and I'll do some stuff in the back end, and then this AI should be able to tell me, yeah, I noticed like you shifted this component over here. The menu looks completely different. Is that what you want, or is this an unintended consequence? What does that mean? Vision AI used to really be a pixel by pixel comparison, so it's definitely gotten a lot smarter to where it can know what certain things mean, rather than saying, oh, I did a pixel by pixel comparison, your pixels were off by 1 because of whatever, and it failed. When you're like, no, it's visually the same. So it's nice to see some improvements there, but I do have some reservations on like how this AI benefits a team. What does it mean when an AI test fails because it looks slightly different? What are the tools? And some companies handle it a little bit different than others. Some have a little bit more of a tool set that you can use to say, yeah, ignore this area, but you know, this area is what you really want to focus on for changes. Another interesting idea was this idea of deep healing. So if you develop code and your test attached to that code, but then a developer comes and changes what those components express, then you're having a hard time latching onto. So a common one is you put an ID on an element. Well, dev comes in and clears the ID. They don't need it anymore. Your test would fail. So the idea of deep healing is you have AI that would see that failure because of that problem and then change the test by itself without you needing to interfere with it and say, oh, yeah, they got rid of the ID, but we can latch onto it by a class name or some other attribute or combination of attributes so that we can attach to it. I think that's a really interesting idea on its surface, but I think it also clashes with that idea of shifting QA left, this idea that it's trying to retroactively fix your test for you because there was a loss of communication, because there's a loss of communication between developer making this feature and what that means for testing. And so that idea is really cool on its head if you don't have the bandwidth. If you do not have a QA team, but you need to have tests, maybe this is pretty helpful for you because it's one less step you have to take. But at the other side, it's saying, I'm just going to change code and our tests are going to adjust to it. It doesn't matter if it's good or bad changes, it's just going to change. And hopefully that's readable and hopefully that doesn't affect anything down the line. But it definitely seemed like there's a disconnect there between the whole software development process. Another one's code generation. A lot like to have the low code generation saying you don't need a lot of skills to generate, generic solutions that everyone generates all the time. That can be pretty cool to see. It also can be pretty risky because you could be generating code that you don't fully understand, or it has side effects that you're not aware of because you're not closely looking at it. So you have to take it with a grain of salt. I would say out of all of the AI solutions, I split them out into these two lists to say yellow's really interesting, but I think it has a lot of edge cases and possible downsides, and it doesn't give these benefits as much as the green ones are. So the green ones I broke out to say these ones are really interesting because they give you more information to inform you as you're developing or as you're doing QA. So you do all these changes, you have all your tests, but then as part of your automation, you have something come in and say, look, I've analyzed based off of the amount of times you guys do changes in this area, you're probably going to have an issue coming down. You might want to spend a little bit more time in this area because in the past, every single time you guys commit in this function, this feature, you guys create like 3 bugs for it. So be aware that this is a dangerous area. This isn't a safe area. Like some areas in our code are super safe and other ones are very risky. It definitely depends on the code base. This tool of risk analysis can be really beneficial because it's giving you more information as you're developing. Same thing with the mobile AI. The mobile AI is definitely more of a focus on, hey, we noticed you made this change. We think that's going to affect like network and performance here and here, and this is why. And we simulated and we think this is going to happen. So having that's pretty beneficial because you make a change. You don't know, oh, that's right, this one edge case, when they're in the top of Mount Everest, like our app completely closes and crashes. Thank you so much for catching that. We'll address that and we'll fix it. Same kind of idea with security testing, just shifting that over and saying, look, you didn't actually think about injection right here. Just be aware. You might want to fix that. The predictive quality models is similar to risk analysis. It's this idea that you risky areas, less risky areas, it kind of gives you this idea of what you need to address in certain areas. It's pretty neat. So those are how I split the AI and saying this is cool, but maybe not super helpful, not really empowering the devs or QA to make better decisions. These ones seem to be a little bit more interesting. And so I just want to go back again to the quality engineering and saying the biggest change between quality assurance and quality engineering is to shift left, to shift all these processes and try to integrate them as much as possible to every other spot of software engineering, to say, we need to do some of this stuff here in design, development, our pipeline, before we even get to where we are manually QAing things. Don't wait to the end to do it. Don't wait to the end to do performance testing. Don't wait to the end to solidify requirements. Don't wait to the end to do your network analysis and your security testing and all of that. Try to shift it left. And if you try to do that, you will start to engineer quality in your product. Thank you. I'm happy to answer any questions. We have a good amount of time. Trevor.
I was trying to do the button that
Oh,
says great job. That was fun.
Thank you.
Thank you.
What was your favorite thing about this conference, Drew? That's my question.
The presenter on the agile metrics and this idea of cargo cult agile just really hit me at a really key moment. And it's really neat to have a presenter that unlocks thoughts that are just kind of always jumbling around in your head, and they're always waiting for something to solidify them. When she started talking about cargo cult agile and like this idea that we adopt this idea and then we expect it to fix everything is known, but like, why do we expect it to fix everything? And why do we get into this idea where we're trying to get all these metrics, but it doesn't seem to be helping us? We're using these tools and these processes, and they seem to be really great, but there's something's not clicking. It doesn't seem to. What's the next push in using this ideology, this agile, to get us further? And that was one of the better presentations at the conference for sure. The AI was pretty neat too, to see how we're trying to introduce this as QAs and address it. It's really interesting seeing those different perspectives, and this idea of shifting left kept coming up in different presentations. And so to see this constant shifting left, hey, we need to do agile, we need to kind of like shift that left where we can, we need to do performance testing, we need to shift that left. And then you have this company come out and tell you something that doesn't really hit the shift left as much, and says, oh, well, you don't really need to do that because AI is going to do that. You don't really need to think about test case design and all this stuff because the AI is just going to make the test cases for you, and the AI is going to heal the test cases that it makes for you, and then it's going to report on the test cases that it created and healed for you. And it's like, at what point, how is that beneficial to our current processes, and how does that empower us as developers in QA to make better decisions? It just seems like a replacement. That replacement could be beneficial, it could not. And that's kind of what I got from the conference.
I like it. Thanks.
Remind me where the conference was?
So this was StarEast. So they have Star West and StarEast. Star West, I believe, is in San Diego or San Francisco, and StarEast is somewhere else. I did the virtual conference, which I was really appreciative that I could do because one, it's not as expensive, which is really nice. I get to do it from home. I get to access pretty much everything that's relevant virtually, and that was really nice. And then I still have these videos to reference for a good amount of time, which is really great. I really appreciated the opportunity to go to the conference. I will say one of the things that was new, because this was my first conference, was to go to a video that someone's presenting, like how to increase, your test case, whatever. And you go to it and they're like, hey, did you know like A, B, and C is really cool? And you're like, yeah. And they're like, but did you think of X, Y, and Z? And you're like, no. And they're like, yeah, so like our product does X, Y, and Z. And you're like, oh, cool. But like, can you tell me of like a way to do that without your product? And they're like, no. It's like, okay, that makes sense. Like, I get that. But when half of the presentations kind of follow that same pattern, it was disappointing, because you're going to try to learn something and you're like, oh, this is just a really good sales pitch. Okay, I'll try to take what I can from it.
Yeah, I agree. That's in general, you have sponsors at a conference, so there's always that interest in having more of the marketing pitch versus actual technical knowledge and learning something from it that you can take and apply without having to buy something, right? So I appreciate kind of the best of both worlds, because sometimes it does make sense. Hey, there's an off-the-shelf product that I didn't know about. That's really cool. I heard about it at a conference. And then other times you're like, oh, well, actually, I just want to learn how to code. Teach me how to code. And so they're kind of these two conflicting goals. So I'm glad that you have conferences that kind of do both.
Yeah, that part is really nice. If it was the latter rather than something informative, it definitely would have been a much more sad process. And you kind of can't catch on something that I noticed too when it comes to these off-the-shelf products. I think something that restricts integration is when they say, hey, you have your tests, now you just need to package those up a certain way, send it to our system, we'll process all of it, and then you have to log into our system and then address issues there. You can't do it remotely. You can't do it through whatever system you're using to test right now. It's going to be completely separated. And I think that might be a really big differentiator when it comes to AI. So I'm taking from personal experience when it comes to this, because currently at our client, we have Cypress, and then they wanted to try out an AI vision tool called Applitools, which sounds really cool on its surface. And the pitch is really cool. And this idea of you're just walking through your application, you're taking screenshots at every step, pretty cool. And then you realize, well, there's two issues. One, super slow, because you're taking screenshots, and every time you take a screenshot, it scrapes it and sends it to their servers where they're going to do analysis on it. The second issue, when you need to fix an issue that it found, you have to log into their system, address it there. And that's one extra step. It makes a lot more, it's that one extra annoyance where you're like, I don't want to do that every time you report a test failure. I don't want to have to go into your system to approve and say, yep, this is the new layout or whatever. So I think when it comes to the AI tools, they'll have the most success if they seamlessly integrate into whatever you're using. And some companies do that better than others. Some are like, yep, ours will integrate directly into Jira. It is seamless. And others are like, no, you need to log into our portal and work with stuff there. And then we like ship it back through an API. I think that's what we're going to see. The ones that are successful can latch into the already existing ecosystems, and they will have the best chance at being usable.
Yeah, totally agree. Thanks so much, Drew.
Welcome. Well, thank you so much for coming, everyone. I really do appreciate everyone that showed up, and I hope that you got something out of one of these lessons that you can either take from the QA side, or you can take and apply to your development side, and just some ideas to mull over. I know one of the bigger ones is Agile, so maybe you took something from that and you can say, hey, yeah, we do velocity. How about we do change that over here? How about we do change that to value delivered? What does that mean for us? Does that help us out? It gives you some ideas. So
Thank you, Drew.
thank you.